Hello. Today I would like to show you how to navigate more accurately in Cliffs of Dover, and I'm going to just to show you an example with 2 waypoints and then a free run. We're going to pass through Dungeness and then Calais. The distance from Maidstone to Dungeness is approximately 30 miles, and the route will be 135 degrees. And from Dungeness to Calais, the route is 40 miles, 90 degrees. We have to calculate our base factor, and the speed we need to know is the true airspeed, and we need to add 1% for every 600 feet of altitude. Therefore, 12,000 feet, 20% over 200 miles per hour, which will be our indicated airspeed. We will fly approximately 250 miles an hour true airspeed. Base factor is 0.25, and the time is the distance multiplied by the base factor, hence the length of our 2 legs. And the route is a geographic route, and when we will follow the path, the magnetic route is equal to the geographic route plus 10 degrees. There is 10 degree difference. We need to add 10, and hence we'll follow 145 and then 100 degree on the compass. Starting up the aircraft, we need to do as usual. So the mixture is a little bit special on this aircraft. Open the radiator, mixture needs to be rich, and a little bit of throttle, and let's go. So the mixture lever, if you are using it on the joystick or directly with the mouse, there is a lean mixture is forward. Lever needs to be forward for lean mixture, and if you pull the lever back to you, then this is rich. So mixture is pulling the lever toward you. And for example, on my joystick, since I have this on a simple sticker, then I need to pull the sticker back to me in order to be rich, and that's special for the Hurricane. And if you have a plus and minus for example for rich and lean, then you don't have any problem. And anyway, the default setting will be rich when you spawn into your aircraft. We're using a little bit of flaps here. I have set to 20 the flaps. So if you use them, don't forget to raise them after you have taken off. And if you checked before lining up, I have set the trim to slightly positive. It helps for the takeoff. And I have also set the altimeter to the field altitude, and directional gyro to the value shown by the compass. Directional gyro is an instrument which remains always useful for you, even when turning, and it is very easy to read. But it needs to be set, and also it becomes fault after a certain time, or if you make very big turns, you need to compare it to your magnetic compass and set it again. It will move. So we are now going to the first leg of our path. This is 145 degrees on the magnetic. And we will set the aircraft for climb. We will climb 140 miles an hour, full power and reduced RPM. So the first leg is 30 miles. And because we are climbing approximately 2.5 thousand feet per minute, we are climbing 12,000 feet, so we will need something like 5 minutes, approximately 5 minutes climb. During those 5 minutes, since we are actually doing approximately 140 miles an hour, this is a base factor of a little bit less than 0.5, and hence 2 miles, a little bit more than 2 miles per minute. So during this time we will go approximately 10 to 12 miles. That's 10 to 12 miles. So this is explained in a paper. I will show you the link. If you want to read it, it's very easy to understand. If you are at base factor of 0.25, then you're doing 4 miles per minute. It's just the other way around. So now we know that we're going to have about 12 miles passed through this 12,000 feet, which I have cut, and we are now in the video. We are now at this point. So we have 18 miles to our waypoint, and 18 miles, this is approximately 4 minutes. Now we are going to cruise with minimum RPM and lean mixture and 2 pounds of boost. This means reduced power. With this setting we can make economy, and we will use something close from 35 gallons per hour. This is a setting for economy and cruise. And so at this point, don't forget to check that the direction is right, and to compare the gyro from the magnetic compass. So the setting is now correct for cruising. If you want to read this PDF file I have done, you will understand how to use basic visual flight rules and stopwatch, and but I want to describe in few words how it works. We have the base factor is calculated 60 divided by true airspeed. The true airspeed, now that we are doing 200 miles an hour at 12,000 feet. 12,000 feet, this means 20% of over indicated airspeed, so we are doing something close from 240-250 miles an hour true airspeed. So the other way around is 0.25 is 4, so 1 divided by the base factor. For 0.3, this will be approximately 3. So this means every minute we are going through 4 miles. This is approximately what we're doing now. Here we have under our right wing the coast at a distance of approximately 5 to 10 miles. If you want to calculate or estimate the distance of something on the ground, for every 6,000 feet of altitude there is 1 mile distance, vertical distance from the ground. So here we have 2 mile distance from the ground. This means that if you're looking below your right wing 45 degree down something, it is also 2 miles from distance from your vertical position. And here this is more like 60 degree, so this is twice 60 degree, it's 4 miles on the right side. So the coast is something like 5 miles distance from us. Now we are passing through this 10 minutes flight, and we are facing Calais. So down to Calais, we know that the coast is at 5 miles from us, so this is something like 1 minute 15 seconds from vertical Calais. We're still stable on the parameters, and the speed will influence your distance crossed on the ground. It can make a very big difference. So we need to check every time that we are right on our path, and we need to have some waypoints on the ground which we are supposed to pass through, and so that we can monitor our position and cross-check that everything is fine. So now I am looking for this airfield under our left wing, and we want to pass vertical through it. So this is within the next 30 seconds, and then we will head more to the south, from airfield to airfield. So as I mentioned, we are now doing 35 gallons per hour, and if you use full power with rich mixture, you are close from 85 gallons per hour. And if you don't lean the mixture, you run with higher power, you will be something close from 45 to 50 gallons per hour with a higher cruise speed. So the method is pick up your map, check the distance and the angle, the heading, add 10 degrees, and know your base factor, multiply by your base factor, use a clock watch, and you can navigate through the points. Or you can use landmarks, and then you have an idea inside of your head how many miles you will be doing per minute. So then you can fly by recognizing the landmarks and knowing how many time you need to get there and there and there.